Hello everybody, welcome back to another live office hour brought to you by Chegg. Today we'll be focusing on domains because this is one of the big topics in Precalculus, how to find the domain of the function. Well, I kind of shouldn't have said that because my first question for you guys is that I have these two functions on the board and I would like you guys to answer if they are the same function. But if you were paying attention to what I said earlier, then you know the deal. But anyways, though, welcome back. If you have been here before, if this is your first time, then welcome. This is the live office hour brought to you by Chegg. On Mondays, we'll focus on trig and precalc. So next week we'll be back as well. You can expect our live stream to continue until the end of May. Mondays from 6:45 p.m. to 7:45 p.m. Pacific time. So for the people just logging, thank you guys so much for coming. My first question for you guys is on the board. Square root of x plus 1 over x minus 2 versus square root of x plus 1 over square root of x minus 2. My question is, are they the same function? Go ahead and type in the answer in the chat. I can see your comment. This is live. And this is the live office hour brought to you by Chegg. For the people who would like to get more out of this, make sure you guys scan the QR code right here. Go ahead and do so that you can get to, more information about the live streams, and also make sure you check out their social medias, make sure you subscribe to their YouTube channel, and all the good stuff. Hello everybody, thank you guys so much for coming here today. Are they the same function? I'm going to answer that in like 30 seconds. All right, time traveler, you feel they are the same, but you're not sure. Okay. It's kind of like, why am I bothering to ask you guys this kind of question, right? But anyways, though, yes or no? Go ahead and leave your answer in the chat, either yes or no. Hey, George, you say kind of, not exactly. Well, if we had to say they are the same function, we are talking about are they the same function for all x in their domains? Be careful now. Today, I would like to focus on domains, and we'll also get into some trig identities domain. All right, let me see who has this already. Oh, many of you guys are saying yes. Ready for the answer? All right, 3, 2, 1. Are they the same function? No, just kidding. No, with a factorial. They are not the same function. Because, here's the deal. Let x, let's say I have a negative number, such as, let's put -3 or something. Doesn't really matter. Plug into here, then we are going to get f of -3, which is square root of -3 plus 1 over -2. Why am I talking about? -3 minus 2. This is negative, let me just do like this. This is -2 on the top over -5. This, because the expression is written like this, we will have to do this inside out. You worked out inside, that's positive 2 over 5. I'm just going to leave it because you will see if I plug in -3 into the g function, then g of -3, this right here is square root of -3 plus 1 over square root of -3 minus 2. On the top, you get square root of -2. On the bottom, you get square root of -5. The moment that you see this, if you're talking about f of x or g of x, if you want to talk about their graphs and all that stuff, square root of a negative number, it's not real. Let me just say, not real. So the idea is that you can plug in -3 into f, but you cannot do it for g. In fact, they are not the same function because their domains are different. So you will have to use this property carefully. You can only do the square root of the top and the square root of the bottom if the top and bottom inside, they are both positive. So let's just talk about how to find the domain. And again, as I said, this is the first question, and I will go over more cases on how we can find the domain of a function. So if you are in trouble, if you have trouble with finding the domain, then this live stream is definitely for you. So here we go. By the way, let me just take a look at how many guests are here already. Audio delayed. I hope it's not so bad. I can't do anything right now. Let me see. Okay. Audio and also video delay sometimes. My internet should be okay, so not sure. Here's the thing. Earlier we couldn't cancel the I because when you see square root of -2, in terms of the domain, no real number. You don't have that. You cannot use that. So let's talk about this right here. Right here, f of x is equal to square root of this. There are 3 things that you will have to know. Oh, okay, cool. Thank you. There are 3 things that you have to know for finding the domain. I will just write this down real quick, right? So for domains, I'll just write this down for you guys. Actually, okay, I'll keep it here so that I have more things to write, right? More places to write. 3 things. First, when you have a fraction, top over bottom, you will have to make sure the bottom cannot be 0. Dividing by 0 is not good. It's not defined. Next, square root. If you have the expression inside, you will have to make sure the inside is greater than or equal to 0. Lastly, when you have a log function, you also will have to make sure the inside, well, it cannot be negative and it also cannot be 0. So this right here has to be greater than 0. These are the 3 cases that you have to worry about to find the domain. If you don't have these 3 cases, the domain is usually just all real numbers. So for this one, the whole thing is inside. The key is the whole thing is inside of the square root. So I will have to do this. I will have to say the inside here, we need x plus 1 over x minus 2. It has to be greater than or equal to 0 because it's inside of the square root. I'm following this right here. And of course, because we have the x minus 2 on the bottom, we will also have to say, let's just put this right here real quick, x minus 2 cannot be equal to 0. Keep that in mind. So now, we're just going to solve for this. There are 2 numbers that we care. Think about how you can make this equal to 0. Put the top equal to 0. X plus 1 is equal to 0. X is equal to -1. And the other number that we care is from here. You add 2 to both sides. You care about 2. Then we can do the number line method. This is the safe way to do it. We have -1 and 2. We can include -1 right here. Let me just put a close circle. But we cannot include the 2, so this right here is not okay, so open circle. Now, pick a number bigger than 2. Let's say 3. Plug in here, you get 4 over 1, which is positive. That means this portion is positive. If you pick a number in between of -1 and 2, that says 0, put it here, you get -1/2. Altogether is negative. Lastly, if you pick a number less than -1, such as -3, put it here, you end up with positive result. And our goal is to look for the non-negative parts. So we want this, not that, and this. So for the domain right here, we go from negative infinity up to -1, including -1, but not including the 2, just like that. So that's the domain for this function. Now let's take a look at this one. If we have the square roots written separately, things will change. Now, the first thing is that because this right here is inside of the square root, set it greater than or equal to 0. So the first thing is x plus 1. It has to be greater than or equal to 0. Next, because we have this inside of the square root, this is inside of the square root by itself, so we will also have to set it greater than or equal to 0. But this thing is on the bottom, the whole thing right here, right? So we will have to make sure that get rid of the negative, because otherwise we'll be dividing by 0. So these are the two inequalities that we have to solve. This right here means x has to be greater than or equal to -1. This means x has to be greater than 2. And this is an AND situation, meaning you have to satisfy both of them at the same time. If you look at x is greater than or equal to -1, it's like this. This is the number line for that. And if you're looking for x is greater than 2, let's make a mark right here, 2, open circle, and go all the way here. And you're looking for the intersection, which is this portion. So the domain is 2 to infinity. You do not have this part right here. So I will tell you, these two functions are only equal when x is greater than 2. But these two functions, they are not equal entirely, because this one right here has this part, this right here, which don't have this part. So that's the tricky part of us using the properties of the radicals sometimes. So be really careful. All right, so ladies and gentlemen, welcome back. If this is the first time that you're here, thank you guys so much for checking this out. If you have been here before, why don't you guys just drop a me, so that way I know that you have been here before. And I know some of you guys are, thank you so much. You guys show up every live stream, right? I know, I really know. And then I remember the names, and I really appreciate you guys that will come back and check out the live stream every Mondays. Let me see. Even though it's complex domain, they are still considered different functions. That's a great question. If you allow complex domains, are they still considered to be the same function? My feeling is no. I think I would say no. I'm not entirely sure though in that regard. But we are going to keep this precalculus level, so it will just be no, they are not the same function because they have different domains in the real numbers. Thank you guys so much for coming back. Thank you. Yes, I know, BB9, Spa, Mashi, General. Thank you. All right. As always, if you guys have any questions, please drop them in the chat. Today, I would like to focus on finding the domain of the function. I do have a couple more prepared for you guys, so I will also be demonstrating that as well. But if you have your questions from your pre-calculus class, feel free to drop them into the chat. This is a live stream brought to you by Chegg. It's live. I can see the chat. Let's do another one. Let's just go ahead and find the domain. Let me just write down the function so that it's less for me to write. Let's say f of x. Let's do this one. Let's do square root of x. Let's just do that. Minus 4 over. Let's do square root of x plus 4, and then On the bottom, let's do x squared minus 3x minus, plus 2. Yeah, cool. Yes, I'm in Pacific time, so yeah, Monday 6:45 p.m. to 7:45 p.m. Pacific time, and we'll be back next week as well. But we still have time for today, so just drop your comments in the chat. I will read them, and then I will see what I can do for you guys. But for now, let's go ahead and try to figure out the domain of this function. All right, why don't you guys try this real quick, and then let me know what you guys have. So in this case, we have two places that we will have to set the restrictions, right? The first case is, let's just do a square root first. The inside of the square root. We have to make sure inside of the square root is greater than or equal to 0. Next, this right here is on the bottom. So we have to make sure that expression does not give us any negative number, does not give us any 0. So not equal to 0. So these are the two conditions that we will have to set up, and then we just have to solve it. Seriously, to find the domain, it's not so bad. I think the reason that many students have problem with the domain is, one, they don't know the word domain, what it means. The idea for the domain is we are trying to find out all the possible inputs for the function. And usually it's the x for the input. So we're trying to find out all the x values that we can use for the function. So make sure you know the definition. And of course, the next thing is make sure you know the three places that you have to worry about. Here, inside of the square root has to be greater than or equal to 0. Here, when you have the denominator, you have to make sure it's not going to give you 0. We have the two places. And now let's just go ahead and solve it. This right here, just subtract 4 to both sides. X has to be greater than or equal to -4. Here, I will just factor it. X minus 1, x minus 2, not equal to 0. This means x minus 1 cannot be 0, x minus 2 cannot be 0, so x cannot be 1, x cannot be 2. And again, we have to satisfy all these conditions. So if you look at the number line real quick, starting with the inequality, that's what I would recommend. Here, let me erase this so I can bring the number line up a little bit. X cannot be 1, x cannot be 2. And then let's just go ahead and draw a number line here. Here is -4, close circle, because we have the equal sign. And we are going to go to the right. So you just go all the way to the right. Now, x cannot be 1, x cannot be 2. So let's say 1 is right here. You're going to erase it and then put an open circle instead. And then let's say 2 is right here, something like that. And then open circle 2 like that. Okay? So that will be the domain. I'm going to write it in interval notation. So the domain, -4 to -1. Sorry, -4 to 1. Parentheses for the 1 because we're not including that. Union 1 to 2. And then union 2 to infinity. Usually, the domains will be written in interval notation, so make sure you also get used to that as well, right? So that's that. Oh, there's a pretty nice question. How about the domain of 1 over log x squared? Okay, I will do that. because I have shown you the square root and also the fraction, it's a great example to do a log function. So, Robert, your question is find the domain of the function. Right here, I'm going to write down f of x. We have 1 over log. Whatever base doesn't matter, but usually if you just have log, this means log base 10, especially on the calculator. But if you're using Wolfram Alpha or like a more powerful computer software or things like that, then you will have to make sure you know what the log stands for. So this is x squared plus 0.5. Okay, first thing first, inside of the logarithm, you have to make sure it's greater than 0. So x squared plus 0.5, it has to be greater than 0, condition 1. Now, condition 2, the whole denominator, which is this right here, the whole denominator cannot be equal to 0. So I will write log of x squared plus 0.5 cannot be equal to 0. Okay, let's just solve it. Right here, if you subtract 0.5 to both sides, you get negative. And this right here is always true. Because when you have a real number squared, it's always going to be greater than or equal to 0. Thus, it's greater than a negative number. So this right here is always true, meaning you have no worry for that part. Now, for this part though, we have to solve for this inequality, right? Let's say log is like log base 10. It really depends on the software that you use, but I would just say log means log base 10. Because what I want to show you is, pretend these two are like exponents. We do 10 to this power and 10 to that power, even though it doesn't matter. Because anything to a 0 power, right? Any non-zero number to the 0 power is just 1. Anyway, so we get x squared plus 0.5 equal, well, not equal to 1. Now, to solve it, subtract that to both sides. X squared cannot be equal to positive 0.5. You minus this to both sides. Then take the square root to both sides, plus or minus. This still works. X cannot be plus or minus square root of 0.5. Allow me to just use decimal inside of a square root. Usually I would just change it to a fraction, but the question was written in decimal, so I will just keep the decimal. So combining all these conditions, we have to make sure x is not equal to plus or minus square root of 0.5. That's all. To write the interval notation, I'll just put this down here. We can go from negative infinity up to negative square root of 0.5, union negative square root of 0.5 to positive square root of 0.5, union square root of 0.5 to infinity. And I know many of you guys might want me to write the domain as real numbers are take away plus or minus square root of 0.5. It depends on your instructor. If they're okay with this, yeah, go for it. It is definitely easier than the interval notation because it's much longer right here, of course. So that is that one. Oh, time traveler right here. We should also have the middle part as well. So yeah, I think we should have 3 parts. All right, so any other domain questions? So far we have gone over square root, fraction, and also logarithms. Really good questions. I do have some more for you guys though. So let me see. Do you guys want to do range next week? Domain and range are very different. Domain is easier. Range, much harder. Do you guys want to do range next week? It'll just be next week. I wanted to do a trig equation with you guys, and let's see how that goes. So let's say we have a function here. If we have this right here, let's say we have cosine of x over 1 minus 2 times sine x. And again, let's find the domain. The challenge for this right here is not about knowing what to do in the sense of like, oh, what domain is. You set the bottom line equal to 0. All you have to do is just put this 9 equal to 0, right? So 1 minus 2 sine x cannot be equal to 0. We kind of know what to set up, right? We know the first step. But the hard part for this one, it's not just the first step, it's a step after that. How to solve a trig equation. We haven't done this for a while, right? Because we did this like many weeks ago for the live stream. So it's a good place, it's a good time to revisit. I'm going to move the one to the other side, so it becomes negative 2 sine x cannot be negative 1. Divide negative 2 to both sides, that means sine x cannot be positive 1/2. Now, to figure out what x cannot be, I would like to do the triangle method, the reference triangle method. So for the sine, this right here is the y value, and the bottom here is the r value. Well, here's the deal. I can draw a picture. I'm going to do like this. Y is right here. Let's say it's 1. Take y to be 1. And the r is this. Take r to be 2. And the third side here is just square root of 3. And as you can see, this right here, you have to know your special right triangles. This is the 30, 60, 90 special right triangle. And this is the smaller side. So this is going to be just 30 degrees, which is pi over 6. Now, you can also go to the other side like this, because that will also give you y being equal to 1, and then the r is still 2. Now, this right here is also pi over 6. But you will have to measure the angle from the positive x-axis all the way to here. So this angle is really 5 pi over 6, because you do pi minus pi over 6. So if you look at the picture, you have two sets of answer. The first one is the pi over 6. So just say x cannot be pi over 6. The other answer is this. Also, you have to mention x cannot be 5 pi over 6. When you have these two first answer, the rest is just that you have to add 2n pi, that's all. So you just have 2n pi, because the period of the sine is that. And for this, because you already have infinitely many answers, just leave the answer like that. Just set that restriction, say x cannot be these numbers, that's all. Right? All real numbers, but not these. We have infinitely many of them though. All right, let me take a look at if you guys have any other domain questions. Log of x squared minus 4, and then over square root of 5x plus 2. Okay, let me try that. But please make sure that for all the domain questions that you can really just do what I told you, the 3 steps. Oh, by the way, before I do your question, why don't I give you guys another one real quick? So let's say we have f of x. Let me ask you, what if we have x squared plus 1, and then I want to minus sine of, let's say, the cube root of x minus 2 or something? What's the domain for this one? Yeah, this is one of the examples that I haven't gone over yet, so let me talk about that. Hello, Ricky. Thank you, guys. Thank you for coming. Thank you for dropping by for the live stream. And then, thank you, guys. All right, for the people just coming, thank you guys so much for showing up. If you have been here before, I really appreciate that. Thank you. And to check out what Chegg has offered for you guys, make sure you guys scan the QR code right here. When you scan it, you will get to see their YouTube channel and then the live stream schedule. This live stream is brought to you by Chegg, and then on Mondays we offer live streams, office hour, Trig and Precalculus. That's what I'll be doing with you guys. Okay, this right here, it's easier than it looks. It might look like intimidating, but no, there is actually no worries. Ready? The domain is just all real numbers. Why? Do we have any fractions, like any over x? No, right? No fractions. Do we have any square roots? No. In fact, no square roots. Technically, I should say, if the index here is an even number, then you have to worry about the domain. But usually for your pre-calculus class, we just talk about either the square root or the cube root. But truth to be told, it's the even root. There's no square root, there's no denominator, right, x in the bottom, and there's also no logarithms. There's no worry. Domain, all real numbers. Just like that. Very, very nice. Okay, let me find the domain question that I'll have to find it. Log x squared minus 4. So log of x squared minus 4 over, and the bottom is square root of 4 minus x. Okay, I see what this is about. We have 3 things to worry about. 1, let's put it inside of the square root. No, sorry, inside of the logarithm. So condition 1, x squared minus 4 has to be greater than 0. That's number 1. Number 2, this right here, let me just use red. This right here, it has to be greater than or equal to 0. So 4 minus x has to be greater than or equal to 0. But the thing is that if you look at this, the whole square root, because that's the whole denominator, this right here cannot be equal to 0. You can combine this two right away. This right here is just saying 4 minus x. It has to be greater than 0. You cannot have the equal sign, right? And let's just solve it real quick. Let's do that. Factor it, you get x minus 2, x plus 2 is greater than 0. Right here, you will care about negative 2 from here, and let's do like this in this order. 2 from here, and then negative 2 from here. Right? And then let's find a number line right here. Negative 2 and 2. Open circle, plug in, and then do the test value. This is just like the standard way, the safe way to do it. Or you could also put this to the other side and then take the square root, but make sure you use the absolute value. But anyway, so you will get this right here being positive, this right here being negative, and this right here being positive. So these the two portions are the ones that we need. Now, as of this, you move the 4 to the other side. Do not switch the inequality yet. Right here, right now, after you divide both sides by negative 1, you switch. X is less than positive 4. So now, let me see. If you put them together, let me see how can I do it. Let me see how to organize this. Okay. So for this right here, it's just like this. It's like a 4 and then open circle and then you go the other way, right? So imagine if you put 4 right here. This is like the 4 that we want right here. So make a mark, open circle, 4. And then you go all the way to the left. So you cover this part and then just cover this part. Right? So it's this portion here. So this is overlapping and so is that. So the domain for this, we go from negative infinity to negative 2. Union 2 to 4. Done. This right here is the domain. Just like that. Could I demonstrate the second derivative of inverse sine x? I'm sorry, we are doing trig and pre-calc here. That's calculus. We are not talking about calculus today. Make sure you check out the QR code right here also to see. So now you can see who will be hosting the live office hour for calculus. Domain of e to the tangent of e to the x. That's actually quite challenging, I'll say. Let's have a look. Finding the domain is actually a lot of fun, I will tell you that. But by the way, you guys haven't told me yet, do you guys want to do the range for next week? If you guys do, please just leave in the chat, say range, so that way I know. And for range, I cannot just do the random functions because for range, you have to do it carefully. There are only certain types of functions that you're expected to know for finding the range, right? For domains, as long as you know those 3 things, you're okay. One thing right here though, tangent of e to the x, you might be thinking, there's no fractions, there is no square root, there's no log, so the domain should just be all real numbers, right? Yes? Yes? No? Yes? No? No. Because when you have tangent, this is secretly a what? This is secretly a fraction. This is sine of e to the x over cosine of e to the x. Now, we have to make sure that the bottom, the whole thing, because the input for cosine, that's all real number, that's okay. The input for e to the whatever, that's all real number, that's okay. But the whole thing, because this is on the bottom, you have to make sure the whole thing cannot be equal to 0. So cosine of e to the x cannot be equal to 0. And when you are solving this kind of inequalities that are not equal to 0, just treat it as solving an equation with equal to 0. Now, cosine of what angle will give us 0? Well, if you take a look at the picture real quick, cosine is the x values, right? On the unit circle, you get 0, 1 here, and then right here you also get 0, -1. The x value here is 0. So here we get the first answer pi over 2. Here the first answer 3 pi over 2. Now, this means the input, which is e to the x, we cannot get pi over 2, and then all you have to do is just keep adding pi. Look, right here. You add pi, and then try and so on, so on. So you can go from here to here, there to there, and so on, so on, so on, right? So all you have to do is just plus pi over 2 and plus n pi, where n is an integer. Right? Technically, I should say where n is an integer. Okay? Now, just kidding. Anyways, I'm going to erase this. I know my whiteboard is not working today. It's still here. I know. Now, be really careful though. Here's the part of the range that you have to know. E to the x, this right here is always greater than 0. So, in fact, right here, this is n is all integers, right? But in order for this to make sense, we will have to make sure n is a positive integer, right? N is a positive integer. N could be 0. How should I write it? Okay, I'm just going to make it super clear. N cannot be negative because otherwise you'll make this expression negative, and e to the x cannot be negative number in the real world. So I'll just say n has to be, let's write it down like this. N has to be either 0, 1, 2, 3, so on, so on. I forgot the notation for non-negative integers. I think this is the easiest way, right? So now, assuming that, then you can say x, just take the natural log to both sides, ln of pi over 2 plus n pi, and then where n is a non-negative integer, and that will be the domain. Yeah, and then again, it has so many intervals. I'm not going to write it in terms of the interval notation. I'll just keep it right here. I'll just keep it like that. Easier that way. You're welcome, Jerry. Let me see what we have. Yeah, I wanted to say n is 0, 1, 2, 3 though. But if you say z plus, this is technically 1, 2, 3, and so on, so on, so on. I want to include a 0, so I kind of don't know if there's a. You can say unions, but that's not nice. I think this is the easiest notation for that. N, if you say n, here the debate is, do we include 0 or not? Do we include 0 as a set of natural numbers or not? This right here is by convention, meaning that there's no agreement. I will tell you that. Does a natural number include 0? Depends on the textbook that you use, depends on the context. There's no agreement in general. Natural number is more of a vague term, in my opinion, because of the trouble number 0. You can say whole number. 0 is a whole number. You can say non-negative whole numbers like this, right? That will be more clear. Natural number, because there's a debate for if 0 is a natural number or not. It just depends on how people take it. Whole numbers include 0. Yes, that is for sure. Integers also include 0. That's for sure. Yeah. 0 is nice because 0 times anything except for infinity, you get 0. But 0 also causes a lot of trouble, right? All right, any other questions? If you're working on any of your pre-calculus homework, if you're also doing domains, feel free to let me know what you have. Okay, then that function x to the x, a to the, I don't think I can do that. I don't think I can do that one. Okay, I see square root of x minus cosine x. That one, I don't think I can do it either. Because it's not because I cannot do, it's because we cannot solve this equation by hand. You can get an answer, but it's not going to be a super nice algebraic answer. Yeah, no algebraic answer for that. piano has 0 and it's natural. Oh, I think it really depends on textbook. Piano, that's more of a set theory, right? I don't think we use W for whole numbers. Plus, when you say whole numbers, it's like, do you mean positive whole numbers or negative whole numbers or non-negative whole numbers and all that stuff? Just kind of reading over the things that you guys are telling me. And okay, good question. How about the range is much more difficult than the domain. Range is more difficult than the domain. Perhaps let's do this as exercise because this is one of the common mistakes I see from my pre-calculus students. All right. So suppose I give you a function. Let's just say I have x minus 5 something. Just a nice function. The domain for this is just all real numbers. Right? So done. No fractions, no nothing, right? But now, what if I want to take away, let's say, 1 from this domain, and I still want to keep the same thing? I want to take away the number 1 from its domain, because right now domain, we have too many numbers. But I still want to maintain the same kind of look, because for x minus 5, it looks like this, right? X minus 5 looks something like this. This is about x minus 5, something like that, right? This is negative 5. Okay. Now check this out. I'm going to say this is like f1 or something. This is my first manipulation or like first multiplication of the function. Have a look. X minus 5 over, this is what I'm going to do. All I'm going to do is I won't take away 1. I'm just going to multiply this by x minus 1 and also divide x minus 1. Now, because we have the x minus 1 on the bottom, x can no longer be 1. So the domain for this right here becomes negative infinity to 1, union 1 to infinity. Because on how I write down the function like this, you will have to respect the original expression, x cannot be equal to 1. Do not cancel. And this is like perhaps the hardest part once you get to the rational functions, because you are going to get functions with graphs, and the graphs have like a removable discontinuity. It's just like a hole on the graph. So the graph of this one, it will be like this. You still have the same shape right here. This is still negative 5, but x cannot be equal to 1, right? So I'm just going to go to 1 here, go down, erase, and then put an open circle like that. And in fact, you can keep on going as long as you multiply the top and bottom by the same factor. Then you can actually keep removing the points from the graph. I think it's pretty fun and pretty cool for that. Audio and video mix matching. I don't know. Is this okay? I can tell. How is this now? There might be a small lag, and I have no idea. But hope this right here is okay so far. We have about a good 11 minutes. So if you guys have any questions, feel free to let me know. Right? Square root of tangent, that is much more difficult because you will have to talk about the domain. And I mean the range. I can try square root of tangent x. You want the domain for that. That is a... Let's see what we got. The function, we have square root of tangent x. Now, the reason that this is much more difficult than if you were talking about the other function g of x, if you had tangent of square root of x. Actually, I take it back. They are equally... how should I say, they're equally difficult because of how you are going to write down the answer and express your answer. Now, for the first one though, wait, this right here, you just have to make sure this is greater than or equal to 0. I just have to make sure it's greater than or equal to 0. So let me just write that down. Tangent x greater than or equal to 0. And it depends on how you want to do this. You can use the unit circle, or you can just use the triangle method and all that. So all right. I'm going to use the graph for tangent. I think this is how we can review the graph as well. If you talk about the graph of tangent, you'll get like this. And this is the reason that for this right here, it's not easy to express your answer because you have so many of these. That's a horrible looking graph. Sorry. Now, we just want anything that's above the x-axis. So right here, the first value is 0. The next value is 0. And then this right here, negative pi. I know I make a horrible mistake. I'm sorry. I mean 0 and then pi. Because when you have pi, you also get 0. And now the issue is, how do you write the answer down for this? You are looking for just this portion from 0 to pi over 2. So I'm going to write it down like this. I don't really have a nice way to write down the answer for this though. I can say the first one, I can write it down like this, including 0, but not including pi over 2. Union, the next part is including pi, but not including the vertical asymptote here is you do this plus pi, which is 3 pi over 2. And then since this has so many, I'm just going to put on union and then dot, dot, dot. Hopefully the reader understand the pattern and then just really write it down. I think that's how I'll do it because it's really not easy to write down the domain for this in an easier way. And negative pi over 2. And then so on. Dot, dot, dot. So that's the domain. Yeah. It's more like this. I can try starting with 0. I'm going to just write it down patterns because the left number is always including. So starting with 0, pi. So altogether we have n pi, right? And then I think I'll just do n pi, which is this number, and then we just add pi over 2. And how do I write down for all this? For n being a integer. You have infinitely many these intervals. I think this is how I write it. I think this is perhaps best I can provide. Yeah. All right. Good morning, everybody. Good morning, everybody. As of this one, make sure you write it down. I'm just going to write this down for you guys real quick. Make sure you write it down as sine of square root of x over cosine of square root of x. And then you have two conditions. Make sure you set this to be greater than or equal to 0. And then you have to set this not equal to 0. Cosine of square root of x not equal to 0. And since we have done something like this earlier, you can try this one on your own. But that one, I think this is the best I can write the answer down for you guys in a somewhat easier way that people can understand. All right, let's see what else do you guys have. All right. I've always wondered if we invented imaginary numbers, why do they work so well in connecting quantum mechanics to even nature itself? That's a great question. I have no idea in terms of that thing seems like impossible at first, right? It seems like imaginary, but the truth is it does have like real life applications. So how did that happen exactly? I think that's just really fascinating. Right? I think sometimes like you're just doing something, maybe even just for the fun of it. And then all of a sudden it's like, oh, you realize that you can actually use this to do something good in real life. That is just amazing. Huh. Okay, we have about like 4 minutes. So let me see if there are any quick questions I can answer for you guys. All right, good morning, everybody. But for me, it's 7:41 p.m. When does this end? Like 4 minutes. Perhaps I can. Hmm. I think it's this one. I believe there's a final question I will write down for you guys. Cosine of 20 degrees times cosine of 40 degrees times cosine of 80 degrees. I believe it has a special. It has a nice number. It has a nice value. So I'm not going to be able to solve it tonight, but you guys can think about it. I think this is the one that has a nice value at the end. I don't know though, but I just wanted to read your comments. Right? Again, thank you guys so much for coming today, and thanks so much for Chegg for hosting this live stream, for sponsoring this live stream. Make sure you guys check out the QR code right here. Just scan the QR code so that way you guys can see what they have offer for you guys. And then next week we'll be back Mondays, next Monday from 6:45 p.m. to 7:45 p.m. We'll talk about trig and pre-calc again. Now, let me see. Square root of tangent of ln x. That I don't know. I don't think I can figure that out in like 3 minutes. But let me just kind of see what you guys have. Best teacher. Oh, thank you so much. Imaginary are not imaginary, they are complex. I think that's a good way to put it. Yeah, definitely. Because they do have like real usage, right? Well, how do we find the limit of that expression? That is beyond the scope of this live stream. We were just talking about trig and pre-calc in this live streams. But if you check out the QR code here, then you can see what the check they have offered for you guys. Oh, did you guys figure this out? I think this is the one that has a nice answer, right? Cosine of 20 degrees times cosine of 40 degrees times cosine of 80 degrees. If you guys have not done this before, it's a pretty interesting one because the number is super, super clean. Will I help with calculus in the future? Not for the live stream wise, but I do have videos on my channel you guys can watch. And again, if you need help with calculus or any other topics such as chemistry, physics, and even computer science, check out Chegg. Right? Just scan the QR code, look around, and make sure you get subscribed to Chegg's YouTube channel and their social media as well. That equation 3 sine x plus 4 cosine x equals 2. Maybe we can do that in the future. Next week, I do plan to talk about how to find a range, like the ones that you should know for your pre-calculus class, such as the quadratic equation or like log functions and all that stuff. Those are the ones that you should definitely know. We will have the live stream next Monday again. Right? It's on Mondays from 6:45 p.m. to 7:45 p.m. All right. And if you haven't done so already, make sure you figure this out. Drop the answer in the chat or maybe in the comment after this video. And again, check out Chegg, scan the QR code, right? And I'll see you guys next week.